Hello, good morning all of you dear students. This is the simplest and easiest way of teaching learning process in our most favorite YouTube channel. Physics Make It Simple by Dr. Rajendra Kobarne, now serving as a principal in Loknete Dr. Bala Saheb Vikhe Patil, Padma Bhushan Awardee, Pravara Rural Education Societies, Mahatma Phule Vidyalaya and Junior College, Dad Budruk. As long as the 12th science oscillation chapter is concerned, this is the lecture number 12, and in this lecture we are going to discuss two short articles. The first article is Seconds Pendulum and second article is definition of angular SHM and its differential equation. Okay, what is seconds pendulum? Seconds pendulum, the title itself suggests the period is 2 seconds, and so that the definition itself becomes seconds pendulum is a pendulum whose period is 2 seconds. A pendulum whose period is 2 seconds is called as seconds pendulum. Very simple definition. We know the formula of period of a simple pendulum, that is capital T is equal to 2 pi square root of L upon G, that I have already written on the board. Put the value of T is equal to 2 seconds because period of a seconds pendulum is 2 seconds. By putting T is equal to 2 seconds, we get formula T is equal to 2 pi square root of Ls upon G. Instead of capital L, I have written here Ls. That Ls is called as length of seconds pendulum. Capital L is a length of simple pendulum, and I have denoted Ls instead of L, that Ls is called as length of seconds pendulum. Squaring that formula in all sides, in both the sides, we get 4 is equal to 4 pi square Ls upon G, and Ls is equal to G upon pi square. That Ls is equal to G upon pi square. As long as this article is concerned, there is a possibility of asking the question in two types. Question number 1, define seconds pendulum, that I have written here. Define seconds pendulum. And the second question is obtain the formula of length of seconds pendulum. So length of seconds pendulum, Ls is equal to G upon pi square, where G is the acceleration due to gravity at a particular place. So from this formula we can calculate length of seconds pendulum. Okay, then now we are going to discuss angular SHM and differential equation of angular SHM. We know the definition of simple harmonic motion, that is linear SHM, linear simple harmonic motion, that we have already learned, and that definition we have prepared by making use of equation F is directly proportional to minus x. That is, restoring force, the magnitude of restoring force is directly proportional to displacement measured from the mean position. That is the definition of linear SHM. The same definition we will prepare while learning the definition of angular SHM. What is angular SHM? Suppose this is a body. That body is oscillating like this. This is called as angular SHM. The body is oscillating to and fro like this. This is angular SHM. This is linear SHM. This is linear SHM, that we learn. This is linear SHM. But this is angular SHM. Okay, like this. And for that purpose, there is a rotational motion. And we know the rotational motion is obtained by making use of deflecting torque, and the body come to its original condition by making use of restoring torque, tau. That restoring torque tau is directly proportional to the angular displacement. There F is directly proportional to minus x in case of linear SHM. Make a comparative study. In case of angular SHM, tau is directly proportional to minus theta. That tau is called as restoring torque, and theta is called as angular displacement. When the body is oscillating like this, then restoring torque, try to restore the body to its original condition. That is restoring torque, like this. This is restoring torque. And angular displacement is measured from this to this. That is angular displacement, like this. This is angular displacement. And body come to its original condition. That is restoring torque. That means angular displacement is like this, theta, and restoring torque is like this. Both are oppositely directed. By making use of this understanding, we can easily make the definition of angular SHM. So, angular SHM is an angular periodic oscillatory motion in which the magnitude of the restoring torque tau is directly proportional to the angular displacement theta measured from the mean position. Here, deflecting torque tau and angular deflection theta are oppositely directed. Very simple definition, dear students. That is a definition of angular SHM. And then now, just like differential equation of linear SHM, we have to discuss today differential equation of angular SHM. So, the first formula we got, tau is directly proportional to minus theta. That means tau is equal to minus c theta. That c is a proportionality constant. That c is called as, I have written here, internal restoring torque per unit twist, or it is also called as torsional constant. It is called as torsional constant. Sorry. The first formula we got is tau is equal to minus c theta. This negative sign indicates that restoring torque tau and angular displacement theta are oppositely directed. Very simple. This is equation number 1. Then we also know tau is equal to I alpha. That we have learned this equation in rotational dynamics, where alpha is called as angular acceleration. Alpha is called as angular acceleration. I is called as moment of inertia of a rotating body about particular axis. And by putting tau is equal to I alpha, we get I alpha is equal to minus c theta. But we know alpha is nothing but what? d2 theta by dt square. By putting d2 theta by dt square here, we get I d2 theta by dt square is equal to minus c theta. Take this c theta on LHS. I d2 theta by dt square plus c theta is equal to 0. This is the differential equation of angular SHM. Again, as long as this article is concerned, two types of question is asked. Number 1, define angular SHM and obtain the differential equation of angular SHM. Definition of angular SHM is by making use of tau is directly proportional to minus theta. So, restoring torque tau, or into bracket angular acceleration alpha, which is directly proportional to angular displacement. And so the definition, I will repeat again. The definition is angular SHM is defined as it is angular periodic and oscillatory motion in which restoring torque tau into bracket angular acceleration alpha, magnitude of that physical quantity is directly proportional to the angular displacement theta, and which is measured from the mean position, where tau and theta are oppositely directed. Very simple. By learning this, we will meet again in the next lecture. Meanwhile, read this, listen this, write this, take a screenshot and do your study. Subscribe my channel and remain alert to listen your physics by making use of Physics Make It Simple. Goodbye. We will meet again in the next lecture.